So this is going to be a little different than my normal teardown video because it's about some work I've been doing with a colleague in Iceland for the past week and a bit. And it sort of collided with actually this really cool recent release you probably heard about called Airbrake. And this is all talking about this issue of, the ventilator shortage that is really critical for a lot of COVID patients. And how do we deal with this? So you probably heard, for example, about how Tesla donated a bunch of what were called ventilators to a hospital in New York. And then people complained or mentioned, hey, these aren't actually ventilators. These are consumer machines, CPAP or BiPAP machines, they're called. So what does that mean, and why does that matter, and what's the relevance to hardware hacking? And this is kind of what I want to talk about, as well as showing you how to actually tear down a few of the machines of discussion and how you can poke at them. So this is kind of a pretty long-winded video. I'm sorry in advance, but there's a lot of kind of interesting stuff that I think would be good to cover. And the first thing is, talking about these machines here, once they were donated, it wasn't, as he discussed, the problem is that you couldn't find the invasive ventilator. So these machines are possible to be used. So the problem with them is that all of them are designed basically to be worn with some sort of mask or something like that. So this is actually a weird one, like a nasal pillow one, but there's normal sort of face masks. The problem is that they blow air in. So these are all for breathing, helping you breathe. And it has, depending on the settings, different types of airflow going into you, and you basically breathe out, and you either breathe out against a constant pressure or reduced pressure, and you just exhale into the room. So if you have an infectious disease, that's not what you want. And even worse than just exhaling into the room, this is obviously blowing air around, so it's going to aerosolize it even more. So there's a protocol that was built out, and this protocol basically is how to reuse these ventilators, bi-level ventilators, they're calling them, right? But remember, this is better than dying, basically. These are emergency protocols. These aren't the way things should be done, but if you had nothing else, this is what you could use. And they basically added, so the actual ventilators, the little thing on the bottom here, the bottom left, the rest of this, right, is you have some tubing. One other issue is being able to insert oxygen in, so that's some of the other stuff you can do. They have monitors because these machines are not designed with alarms or anything. They're normally not critical for these types of operations. So there's an external machine, but if you had more of them, again, that's good, that can serve as the alarm, as well as viral filters and stuff like that. And in this case, you have this can be used with intubated patients. There's other work that's done to sort of source viral filters to the actual machines themselves. So there's a bunch of ongoing projects related to that. But the problem with this, so if you look at the machine they use, they very specifically have the type they're donated, VPAP ST. And so the type of model here is actually really critical, because if you look at here is 3 ResMed 10 series models. So 2 of them are the same, one's different, you can see, but there's actually a whole bunch of different models available. The most common model, and this is what a lot of people will have, is what's called a constant pressure. This would be your CPAP machine. And so this thing here, if we just turn it on, and what you have is, let's get some, there you go. There's different modes. So, they have a mode they call auto set, which is basically just automatically adjusting the pressure. You could set it to classic constant pressure, where I just set a pressure, and this is in centimeters of water, which is the measurement they're often using. And so if I set a pressure of 5, for example, it's going to continuously output a certain pressure to the output port. So to use this, so to demonstrate it right, the other half of this is there's a little water tank that helps humidify it, so I'll plug that in. And if you turn it on, it's just going to output a fairly constant pressure out the rear here, right? And so that's just going to be the pressure that's always coming out of this thing. So that's your sort of normal CPAP machine. They're auto set versions, so there's something called auto set, and this just means that it has an ability to adjust the pressure over time and stuff like that. So, that's just sort of their more advanced protocols, let's call it. So here's a higher end machine. This is a AirCurve. So what AirCurve means is this is actually a bi-level. So there's 2 levels. If we plug this up, that it's going to be set to. So you'll notice it looks a little different. The 4 Hz. So you'll notice this one, because this is a 4 Hz. So there's an auto set as well that's not for her. This one has flowers on it. They make the menus pink, so that's the main difference, really. Airplane mode, I don't want to turn that off. So if we enter the clinical mode so that we can see the options, right, you'll see there's an IPAP, inhalation pressure, and EPAP, exhalation pressure. There's different modes here. So there's the classic CPAP mode, but they have different modes. So this has V auto, so it's like sort of automatically adjusting. The ST mode referenced here, though, is not present. ST has a special timing mode, so there's actually a little more to these different modes than first meets the eye. But if we run this one, for example, you'll see that it is showing kind of going between 2 pressures. So I'm just covering and uncovering this to simulate it. So when I inhale, it's going to try to reduce the pressure, or increase the pressure, sorry, and when I exhale, it reduces the pressure. This actually lets me set a higher pressure on the thing. So there's quite a bit to these. What's of the most interest, though, is this other model I have here, which looks just like an auto set for her. You might notice, right, that these look very similar. So if we look at these 2 models, you would probably be pretty easily convinced that, hey, this hardware actually looks like the same. There's, faceplate's different, and the name's different, and there's some labels in the bottom that are different. But, how different are they? And that was a question sort of spent the last little bit trying to answer. And what you'll see, so when this guy boots up, you'll notice there's a special message. And it looks different. It's not pink. Preparing SD card, yeah. It doesn't have the pink menus that the auto set for her had. And it instead offers the V auto mode. So this is now functioning as a BiPAP machine, because ultimately it is just firmware differences that affect what it's able to do. So you can actually flash from one device to another device. And that was kind of the point of a site I was setting up with his colleague in Iceland, René. And we basically were showing how it's possible to flash from one device to the other. A slightly more advanced version of this, or actually much more advanced version of this, was shown with AirBrake. So rather than just flashing the units, you can actually specifically enable features without needing the other firmware. And what's also really useful is that you can add additional stuff in. So these devices being designed for breathing support in like CPAP and sleep apnea stuff don't actually have some of the alarms and stuff. This is part of the issue here. And so it's plausible that in fact some of these alarms could be added to the firmware. So we could do a lot more with full control of the units, which isn't anything I was involved in originally. That's that cool AirBrake project, but you can see it's a really big step towards making these things useful. So the first thing I'll do is tear it apart and show you what's inside it. And then we'll take a look at some of the devices in more detail. So let me just clean all this off before I start. Okay, so how do you actually get at these units? It's actually pretty straightforward. So the first thing we'll do is take there's kind of a cover faceplate that comes off, and so the easiest way to do this is just from the bottom. We're going to kind of bring a little some sort of sharp edge. You'll notice there's a little like thing that looks like it's actually designed for this, but I just kind of go along and it'll just pop up. And you can do this without leaving a mark really easily. And so you see this faceplate just pops right off. There you go. The next thing is this knob to come off here. And so this is just a little encoder wheel. Ideally, if you want to kind of pull from both sides or pull a little, rotate, pull a little, rotate until you get it far enough that you should be able to just slip it off, because you have this knob here, right? And you just don't want to bend that too far. With that off, it's just these two screws on the front to remove. 1 and 2. And then what you have is there's one piece that goes basically from down here over top and into the back here. So this is one little piece that we can pop off. And you should do this from the front. So again, I'm just going to use this little kind of knife thing to try to pop this off. Come on. There we go. So there's just a number of latches along there that just have to come out. We'll pull up, so you'll want to clear kind of everything here. And I'm just going to pull up and then engage. Oops, in the back, I forgot, sorry. Just going too fast. There's 2 screws at the back you have to remove. Don't forget those, like I just did. So if you remove these 2 screws first, then it'll just pop off. 1 and 2. There we go. Okay. And now, so for the back thing, what you'll notice is basically there's sort of some, let's see if this will focus enough for you to see. There's some legs that stick down right here. So what you don't want to do is try to, there you go. What you don't want to do is try to just pull this off, because you'll just break these little legs off, right? So you want to pull up and then out. And same thing when we put it back together, right? You have these little legs here, so you'll want to make sure that you sort of get them to engage almost at an like that first, right? So that this is flush at the back. And then I'm going to pull the front around, so we'll see that afterwards. So again, the removals, or the reinstall is sort of the opposite of that. So kind of comes off the whole thing like that. On this unit itself, so I cheated here. This is one I was playing with. What you should do as well is if you want to take this side cover off, which you don't actually need to necessarily, you'll want to take the SD card out just so it doesn't catch there. And you also have a little modem connector. So this one I had already removed it, but there's a little 4-pin modem connector that by default will be on. If you're reflashing the unit, you'll want to remove that so that it's not always active, because the firmware can be re-updated over this, and it's likely to confuse the backend server. So you want to remove that little connector. If you just need to access the programming, so the programming is under this cover here. The easiest way to access it is to pop the bottom 2. So there's 2 little things here. Let's just zoom in a little, right? So 1, 2, right? And you can see it just came up a little bit. All I'm going to do now is squeeze on the side here and the other side here, right? So you can see where it goes through the circuit board. And if we squeeze on both those sides, it actually should more or less just pop up. Right, so again, I'm just at the two latches going through the board. I'm going to squeeze, and you'll feel, I think only one of them came. There you go. The whole thing will just kind of lift up if you get this just right. So there we go. It is a little, so watch, you can see here, right, you have the joystick. You have at the top a switch, so you can kind of unhook it once it's loose and then pull forward. Be really careful, right, when you're doing this. There's a switch at the top that it's easy to bend back. If you do damage that, so I've confirmed the part number. There's a DigiKey part number here. So this SW851ND is a replacement switch. So this is the exact button used on the device. And the other stuff here, just for reference, if we take a look at this device, there's a connector here to the hose cable. So there's a heated hose. And then there's a power jack as well. And the power has DC power as well as like an identification number. But if you just want to reflash it, so if you're interested in like the air brake or the update we show, you have a connector here. This type of connector is called a tag connect. So it's a proprietary connector. Actually, you can buy the cables. And what it's designed to do is it just allows you to plug in without, so there's no actual connector cost on the PCB. That's why people like it. It's really cheap, right? So this just plugs in here. The pinout of this is non-standard, so this tag connect actually goes to several different devices on the board. Normally it would just be one board, so I have a little adapter PCB I've milled out. But you can also just do this with, you know, bare wire or anything like that. So it's pretty easy to connect into. So that would be all that's needed to access the programming port on this thing. If you want to do a little more teardown, I'm going to take it apart further here to show you what else is involved. So a few things on the bottom right here, there's a heater cable. So this is just a little connector that goes into underneath here. There's actually a PCB, aluminum PCB, that has a trace-based heater on it. And so that heats the water tank that plugs in here. You can see the air runs through here to humidify it before going out. So we can unplug that. Maybe I'll do that after I pull the board up a bit. There we go. Unplug that. At the top here is the heated hose connection, as I mentioned. So this is just a flat flex cable. This connector just pulls out, so it's just like a standard sort of flat flex. And you'll notice there's a little key, so when you plug it back in, just make sure you have the key the right way around. To get the power connector out, the power connector is basically just, if we look down here, there's a bit of a latch that you can kind of see. So if you press in on the latch, it will actually just sort of pop up. Let's just pull this up. Okay, there we go. So it should be really easy, but as you can see, it can be a little sticky. So it's just this thing on the side that I was trying to push in. So there we go. So from there, the board's actually more or less free. There's some ports that are plugged in. So you can see two up at the top here. And there's one more that is a little, you can't really see from here, but underneath the board. So you can sometimes just wiggle it out without removing the side connector now that this is free. But what you'll often find easier is to remove this side. To do that, again, make sure the SD card is empty because that's going to really screw you up. Actually, you should have done that before you touched anything else. But there's just two screws at the top here that allow you to remove the side panel that has the modem. So if we remove the side panel with the modem here, this is the modem board. I already unplugged it, of course, so be sure of that. So this modem board actually, if we take a look at that really quickly first, there's a Telit module on it, and this is sort of your GSM modem. There's a few, so there's a SPI flash chip here, and then some power converters and stuff like that. On the other side, so this whole thing has tons and tons of different micros in it. It uses a Renaissance. Let's see, is that enough? Uses a Renaissance microcontroller. So every part seems to use a different microcontroller. So here's the other side. So you have a Renaissance micro with presumably the programming adapter. There you go. And this one looks to have like an eSIM or something actually. So you can see there's like a multi-layout pad here for a SIM card reader or stuff like that. So that's the modem board. Plug that back in. Now this board, the main board will come out. So let's pop that off. Boom. If you do that, you'll then have a connector down here for the motor. So let's move this out of the way so you can take in the board. A little tour around it, right? So we have the JTAG connector I mentioned before, tag connect. You have here a motor driver, so you can see the motor driver IC, plus the different, so there's like a 3-phase motor driver. So this is presumably a 3-phase brushless DC motor is in the actual pump itself. Modem connector up here, SD card. This little guy here is, it's a Lattice semi part. I think it's POW 605. It's like a reset monitor and voltage monitor. Your main LCD here, buttons, right? These are the front panel buttons, just go through, encoder, stuff like that. And some other, I didn't actually spec out what all of these other parts are, but presumably some conversion and measurements and stuff like that. You'll notice there's a few sensors. So there's a sensor down here. So I didn't actually check what all they are. Presumably it's like humidity or temperature, stuff like that, to sense the ambient environment. Gets more interesting on the other side. So here's the other side of the board we haven't seen yet. So you have your main micro, an STM32F405 micro. You have some external memory, SRAM here. 2 oscillators. Right, so your main oscillator and your clock, like 32.76, 8 kilohertz low power crystal one. Backup battery here to keep SRAM alive in this guy. What else is of interest? So there's a bunch of, you can see there's all these resistors going to the I/O line. So it looks like every I/O line basically has some driver. I mean, this thing, because it's a consumer product, right, there's going to be lots of concern around ESD and everything like that. Tons of test points over the whole board. It's just littered with them. So what's kind of interesting for the controller is there's actually 2 pressure sensors. So there's one here, and you can see one port is going in somewhere, and this other port's just exposed, just open. So this one's kind of like a pressure relative to the ambient. So this is actually measuring the output of the pump. So if we look at where these are going, this sensor here is plugging in right here. And that's basically right here, which is like the output. The other 2 are part of the actual pump itself. So it's measuring some pressure across differential point of within the pump. So the other 2, you can see there's 2 pressure ports, and so what it's doing is it's measuring the pressure between these 2 ports, which is part of the control loop for the pump, presumably. There's some sort of accessory connector as well. There's the connector for the pump itself. You also have, so in terms of programmable devices, right, we had STM32F4, we had the Renaissance thing in this guy. And you also have a STM32-8, which you don't see too much anymore. But there you go. There's an STM, not 32, sorry, an STM8. So this is an 8-bit device. And so this is actually what they're calling the humidifier controller, which is basically just controlling this resistive output. So under here, if you open this up, which we can do, what you'll see is a PCB that has a resistance in it. And from that, it's driving the humidifier. So if we open this up, so there you go. So under here, this is actually an aluminum PCB. So it's like printed on aluminum, and you can sort of see the trace outline there if I shine it in the light. There's a little NTC, so negative temperature coefficient sensor, so the resistance goes down. I guess that means with increasing temperature, right? So that's very common. And then this is like a temperature fuse, right? So if it really screws up the control loop, presumably that fuse is going to pop, and that's going to save your device from catching on fire. But that's all done by the STM32.8 device, or I keep saying 32 because that's normally what you'd have after STM. The STM8 8-bit device is just running that humidifier controller there. What else is on this board that's of interest? There's a little flash, so other programmable stuff. There's a little old, this is not called a SPI flash in the data sheet. It's called a SPI EEPROM or EEPROM. And it's just like 2 megabit in this case. So it's a little 2 megabit flash device used to store some configuration information and stuff like that. The rest of it is, I think, just a lot of driver ICs and whatnot around it. There's the pressure sensor, the other pressure sensor box here, and support for that, as well as whatever the accessory port is driving. So that's what's actually inside one of these units. And this board looks identical. So to the question of what's the difference between AirSense, AirCurve, all that stuff, a lot of this stuff looks pretty much identical. Of course, we can't definitively answer that, but we can sort of investigate a little further. If I take this pump off here, this is the pump used to generate your pressure, right, for the unit. So what you have is an inlet pressure, so there's just a little filter on that. 3 screws hold it together. And we can pop this apart, just see what else is happening inside it. And here we go. Okay, so I don't know exactly how these things work, but you can see the pressure ports here are basically being translated to these 2 ports. So one of these ports, you'll notice, goes through this sort of whatever this thing is here. And here's the actual internal motor itself. Right, so one of them is measuring on the other side of this kind of like baffle plate. So it's measuring. It seems like it's measuring the pressure differential between the 2 sides of this baffle plate. And then remember, the output is, where's the output actually? Okay, it's on this side. So this would be your output here, coming out of this little chamber. So so that's kind of what's involved in these things, as well as showing you how the connection, oops, forgot this, which goes with the nice cutout for the wires. And this goes back. So this is what's showing you, what's actually inside one of these units. You can see it's not super complicated. I mean, there's obviously a lot that goes into them, a lot that goes into the actual algorithms themselves running on this. But the sort of important part about this whole thing is that it's plausible to actually run different algorithms on these with the same hardware. So the hardware itself doesn't appear to be limiting what's actually possible. So your real limit is in what the firmware is running on this, and this includes running the more relevant modes of operation that are really critical for use in and potentially as an emergency situation for COVID-19. So, this is really better than dying type situation where you're using this consumer device, but it's something that they've already established some protocols for. And with more work, it might actually be interesting to see how far you can push this stuff.